Newton's third law of motion. For every action, there is an equal and opposite reaction. Let us consider the recoil of gun. Let us consider the recoil of gun. Let us consider this as the gun. So here you got the trigger. Now the bullet is accelerating in this direction, and you can experience the reverse force, that is a recoil of the gun here. This is called recoil of gun. So this is the force of the bullet when it is fired. Let me consider this F1. The equal amount of force is given in the opposite direction, minus F1. Minus indicates the negative direction, that is opposite direction. Law of conservation of momentum. Next topic. Law of conservation of momentum. Momentum is represented by P. So P is equal to mass into velocity. Initial momentum is mu. Final momentum is mv. Okay, because u is initial velocity, v is final velocity. So the change of momentum means that is delta p, which is equal to pf minus pi, that is mv minus mu. So this is the change of momentum. The rate of change of momentum means delta p divided by delta t, that is equal to mv minus mu divided by delta t, the change in momentum with respect to change in time. So simply speaking, this rate of change of momentum is called force, and that is why we call it m of v minus u divided by t. So that is the force. It is called ma, where a is acceleration. So according to Newton's third law, F1 is equal to minus F2. It means the force experienced here is equal and opposite to the force experienced after collision. It means this F1, let me consider two bodies. They are moving in same direction. Let me call this is m1, this is m2. This moves with velocity u1, this moves with velocity u2. Then after some time they get collided. So they get collided, and there is an exchange of force, that is force of, let me consider this is A, this is B. So the force of that is this body, that is FAB, acts on the B. Similarly, this force acts on A. So FBA during collision. And after collision, what happens? That is this MA, okay, it picks up final velocity V1, and this is M1, and there is no change in mass, and here it goes with V2, M2 here. So the force is, in this case, the change of momentum in a given time, means in a same time. So in that case, what is the F1? F1 is, let us give M1 before collision, is it not? So the change of momentum before collision and after collision. So M1 V1 minus M1 U1, this is the force experienced, is equal to minus of, and then open the bracket, M2 V2 minus M1 U1 U2. Okay. So what is the V1? Final velocity of the first body. Initial velocity of the first body is represented as U1. So the change of velocity of the first body, the change of momentum of the first body. What about this? The change of momentum of the second body. Actually, this is force, but it takes place in the same time. So let me strike out this T. Okay. Now this is only change of momentum. Are you able to follow? So that is equal to, now let me put M1 V1 minus M1 U1 is equal to minus into plus minus. So M2 V2. And what about this? Minus of minus plus. So M2 U2. Right? Now I can bring this M2 U2 on the left side, is it not? So, and this one on the right side. Okay, you can interchange it. So this is M1 V1 minus M1 U1. What about this? Minus M2 V2 plus M2 U2. So what we are going to do this, bring this M1 U1 to the right side, M2 V2 to the left side. Okay. So we have M1 V1 minus becomes plus M2 V2. Okay. What about this? Minus M1 U1 becomes plus. So M1 U1 plus M2 U2. And what about this? M1 V1, M2 V2 means the total momentum after collision, is it not? Because that is the final one. What about this? Both of them are U, means initial. So the total initial momentum. So from this, one point is clear. That is, total final momentum is equal to after total final momentum is equal to total initial momentum. It means the total momentum after collision is equal to the total momentum before collision. Are you able to follow? Okay. So this is called the conservation of momentum. So what is conservation of momentum? Conservation of momentum is, during the collision, the total momentum before collision is equal to the total momentum after collision. So this is the derivation of conservation of momentum. Is it clear now?